right, in this section we're going to be talking about a very special piecewise function. So let's look at this one. It has three pieces, 5, 2, and -3. Now remember what that really means. That means we have horizontal lines. When you have the equation y equals 5, that's a horizontal line at 5. And so forth. So let's see. This looks good. That'll be my x-axis, y-axis. Now, y equals 5 if x is greater than or equal to 3. So here's where y is 5, and it's going to be a horizontal line, starting when x is 3. And that did say or equal to, so that's a solid line, and goes on forever that way. The next piece is the line y equals 2 between -4 and 3, including -4. So here's where y is 2. It says we're going to start at -4 and go up to 3, but not include 3 because it's already included up here. Okay. The next one says y equals -3 if x is less than -4. So y equals -3 from that point to the left. This is what is called a step function. Looks like steps. Now, the domain of this step function, or our domain, our x values, goes from -infinity. Looks like there might be a break, but no, it jumps up. Comes over here, and it jumps up. And then it goes on that way. So our domain would be -infinity to infinity. Our range, however, range is really interesting on this one because the range, again, is your outputs. Well, my goodness, our outputs are only that one, and that one. It's just singular ones. So that's when we use our roster notation. We'll have -3, 2, and 5. Now these step functions are actually, there's a lot in real life where this is what you have. This is when you don't have a gradual change. All of a sudden something just changes. My biggest example used to be postage stamps, but nobody buys stamps anymore. So let's take the price of gas. Okay, so I get up this morning and the price of gas is such and such. And it may stay the same for a couple of days. Then all of a sudden, you go there one day, and it's jumped. And that may stay like it is for a while, and then it may jump again. Hopefully, one of these days, it'll jump down. But it doesn't change gradually over the day. All of a sudden, some guy goes out there and changes the sign. That's an example of a step function. Now, there's another example of a step function that's pretty popular, and if you do the investigation that goes with this activity, the discovery, you'll get to play a lot more with it. I just want to introduce it here in the video. The function is called the greatest integer function. The greatest integer function has a funny little symbol. F of x equals, and it's a double bracket with x in the middle. Okay. Now, if you choose to look at this on your calculator, you might want to know that this is in the calculator is called int for integer of x, and it's found as one of the math features. You would go math and then arrow over to the number. But right now, I just want to talk about what it is. The greatest integer function gives you function. How did I write funger? Integer funger. Okay, so this would be function. Don't know how I did that. Okay, the greatest integer function. Let me get my graph ready. and we will talk about what it is. The greatest integer function gives me the greatest integer less than or equal to a number. So maybe the easiest way to start on this is to look at what it means. If I had .1 in there, the greatest integer less than or equal to 2.1 would be 2. Now what if it had actually been a 2 in there? The greatest integer less than or equal to 2, well, is 2. What about 2.5? Greatest integer less than or equal to 2.5 is 2. What if it goes to 2.9? Well, the greatest integer less than or equal to 2.9 is 2. But when I get to 3, it jumps up to 3. This is another example of a step function. So if I were to write it maybe as a piecewise function, and just for part of it, let's do, heck, let's start at 3. We just figured out that when x is 3, my y value or my output is going to be 3. When do you think that's going to change? Well, it's going to change. I know 3.9 will still give me a 3, so it's going to change right before I get to 4, because that's when it's going to jump. Now 2, we looked at that. It started at 2 and went up to 2.9, and I bet 2.99999. And then when you got to 3, you jump. So it's going to be at each integer that we jump. The output is 0. From 0 up until right before I get to 1. And once I get to 1, it jumps up. -1. It's going to start at -1 up until right before we get to 0. -2. -2 up until right before we get to -1. So it ends up looking like this. When x is 3, our output is 3. Now when I get to when x is 4, I'm going to jump up. So you end up with these nice little stairs. Now this is a function just like any others. We can translate it, move it, and that's what you'll learn about in the activity, that we can actually, add 3 at the end and move the whole thing up. If we minus 3 there and move the whole thing to the right, and so forth. So in class, we did the discovery worksheet together. So I want you to try that on your own if you were not in class.